Today we're going to start talking about quadratic functions. Quadratic functions are functions that are of the form y equals ax squared plus bx plus c. We've already seen this as we've been working through solving for x. Now we're going to be starting to do some more facts and information regarding quadratics. One little detail that we're going to talk about is this. This means it's a function. And we'll talk more about that later. But all you're doing is replacing y with this phrase f of x. Ax squared plus bx plus c. Same thing, you're just changing it. Instead of writing y, you're writing function of x, or f of x. Now, minor details. As we move in, we're going to start talking about the very basic quadratic, and that is y equals x squared. Now, this basic quadratic, y equals x squared, to give you an idea how it's going to work, we're going to take a table of values and plot a few points over on the right hand here. So all you're doing is subbing x into the equation, so negative 3 squared is 9. Negative 2 squared, 4, 1, 0, 1, 4, 9. Now you know this basic shape, it's quadratic, and we're going to plot it. I'm going to give you some fun here. We're going to have our negative 3 and 9. So negative 3 and 9, right there. Negative 2 and 4. Negative 1 and 1. And then as you go, it works back up like that. Now, these happen to be a little large, so we're going to make them smaller. See if we can make it smaller. Nope, we can't. So, if you connect the dots, you're going to get a parabola. So, when graph makes a parabola. Now, everything we're going to be doing involving quadratics is going to be based on this parabola. So this is our basic y equals x squared, as you can see from the table of values. But what we're going to be doing are transformations or translations. So basically, we're going to take this same quadratic and move it around different places. And the equation y equals ax squared plus bx plus c will be based on the transformations. But we're going to get into that later. That's just a basic, quick little introduction to the simplest quadratic, y equals x squared. Now, a couple of other pieces of information. This right here is called the turning point. Or, I prefer to use the phrase vertex. And what happens when you're dealing with a parabola, this is the lowest point, or highest. Basically the minimum or maximum. So it's the lowest point in this particular one, but if we were to take that same quadratic and flip it upside down, all of a sudden that's the maximum point. But we'll get to that again. That again we'll delve into a bit later. Now, the first thing that we need to be able to do is very basic, solving for y and solving for x by substituting. I'm going to do a couple of these examples. This particular example, we have x equals 0. So, if x equals 0, sub x equals 0, sub in and solve for y. This one's pretty straightforward because y equals 2 times 0 squared plus 4 times 0 minus 5. So y equals negative 5. This one's really important that they pick this because when x equals 0, you're crossing the x. Sorry, I got that wrong. You're crossing, you're crossing the y-axis. So it's called the y-intercept. Now, if we're doing b, x equals 3, we sub that in, y equals 2 times 3 squared plus 4 times 3 minus 5, 18 plus 12 minus 5, y equals 25. So very important to realize that means you have a coordinate point, x equals 3, y equals 25. Point on the graph. In this particular one, x equals 0, y equals negative 5. Okay? Now, gets a little more difficult. Now we're going to use, we know what y is, we need to solve for x. We've been doing this a little bit. So, y equals 15. So, 15 equals x squared minus 6x plus 8. We can't factor or do any of that stuff until we get this equal to 0. So, subtract 15 from both sides. 0 equals x squared minus 6x. 8 minus 15 equals, doesn't equal, I don't have an equal sign there, equals negative 7. So I want two numbers multiplied together. What times what equals negative 7, and plus equals negative 6. So negative 7 times positive 1, negative 7 plus 1 gives me negative 6. So 0 equals x minus 7, x plus 1. So x equals 7 or x equals negative 1. Now what this means, if we were graphing this, when y equals 15, so y is 15 at x equal to 7, and at x equals negative 1, the parabola passes through those points. So somewhere along here, you have 7 and 15, negative 1 and 15. So that's solving for x and solving for y.